Okay, so this is the second video I have on balancing chemical equations. If you haven't seen part one yet, I strongly recommend that you look at that one first because this one builds on what was done before. Balancing the following equations. If I look at this, first thing I'm looking for is, are there any groups there? Yes, there's NO3. It's there at the beginning. It's there at the end. I'll treat it like one thing. And now going from the left so I don't miss anything out. Cu, copper, one of those on the left-hand side, one of them on the right-hand side. Cl, 2 on the left, I need 2 on the right. I need my coefficient, I needed 2 for AgCl. Ag is the next one. I start with 1, I already know. I end with 2 because my coefficient tells me I've got 2 of the whole unit, the whole formula, AgCl. I need another coefficient here. Now, NO3, lastly. 2 AgNO3 means each of them contains NO3, that's 2 altogether. And on the right, I've got NO3 twice. Everything balances. Second one, Na2SO4 tells me 2 Na on the left. I need 2 on the right. Also, coefficient, it balances. 1 SO4 group to begin with, 1 SO4 group at the end, that's fine. Ba, 1 on the left and 1 on the right. And now, lastly, Cl2, BaCl2, 2 Cl's, 2 chloride ions, and because I've got 2 NaCl, I have 2 on the right also. Often works with an equation like this, that the last element we look at is already balanced because of coefficients we put in. Next, I see 2 groups. NO3 on the left stays as NO3 on the right. I'll treat it like one thing. SO4 on the left, SO4 on the right also, I'll treat it like one thing. So 4 things to look to balance. Al, NO3, Mg, SO4. Al on the left, I have 1. Al, NO3 3 times, contains only 1 Al. On the right, Al2. I need 2 on the left to balance the 2 on the right. We're done. So Al now balances. NO3. In AlNO3 3 times, I've got 3 NO3 units. My coefficient tells me I've got 2 of the whole thing. That's 6 NO3 units. I need 6 on the right. Mg NO3 twice gives me 2 NO3 groups. I need 3 of the whole thing. Next, Mg. Mg, only 1, and MgSO4. And now, because of my new coefficient, I've got 3 Mg on the right. I must have 3 MgSO4 to begin with. Last, my group SO4. In MgSO4, I've got only 1, but I've got 3 SO4, MgSO4 formulae. I've got 3 on the right, also in Al2, SO4, 3. And once again, we find the last thing that I look to balance is balanced already. Check. 2 Al, because 2 Al NO3 3 times. Al2 on the right balances. 4 NO3. 3 of them in Al NO3 3 times. I've got 2 of the whole formula. I've got 6 NO3s altogether. On the right, MgNO3 twice gives me 2 NO3 groups. I've got 3 of the whole formula, 6 altogether. 3 MgSO4, 3 MgNO3 twice. Mg balances. 3 SO4 units on the left. It's Al SO4 3 times on the right balances. One more. To begin. Now, first thing I see, the CO3 group does not stay as a group. I have to balance for C and for O separately. I've got Fe2. So on the right, I need 2 Fe again. Balances for iron, balances for Fe. Treating carbon C and oxygen O separately. I've got 3 CO3 on the left, so I've got 3 C atoms. I need 3 CO2 on the right to balance. For O, CO3, that's 3 oxygens, but I've got it 3 times. That's 9. On the right, CO2 contains 2 oxygens, but I've got 3 CO2. That's 6 altogether. I need 3 more. 9 on the left. I need 9 on the right. I get my 3 more by making it 3 H2O. H. Only 1 to begin with. 6 on the right at the end because I've got 3 H2O. I need to have 6 here. And for Cl. 6 HCl means 6 Cl units. Look at this, FeCl3. But I've got 2 of the whole formula, 6 altogether. Everything balances. One more. This has been called the nightmare. I'm not worried. I see O2 on its own. That's all I'm saying for now. I'll pause, give you time to pause the video if you want. So I always say balance the element last. You can put what you like in front of the O2. It won't affect anything else. To begin, going from the left, only Pb, N, and O to think about. 1 Pb to begin with, 1 at the end. Great. Nitrogen, N. 2 NO3 groups, that's 2 Ns. I need 2 at the end. 2 NO2. Pb and N balance already. Now my element, O. NO3 2 times, that means 6 oxygens. I've got 1 with PbO. I've got 4 with 2 NO2. That's 5 altogether. I need 1 more, but it's O2. That would give me 7 altogether. No problem. Numerically, I can make this balance by doing that. Not allowed in my final equation, but okay in working out. So what we did was to add a half in front of the NO2. Right, now O2 balances. N, I've got my 2. N balances. Pb, I've got it here. We're done. State symbols just tells me the physical state that I find something in a reaction. S for solid, L for liquid, G for gas. If something is dissolved in water, we call it an aqueous solution, and we abbreviate that as AQ. And all we do is to indicate the state of a substance by using the state symbols. Sodium metal. That tells me that sodium is there as a solid. In goes my S. Reacts with water, H2O. Water is a liquid, L. A solution of sodium hydroxide, aqueous solution. We saw that in the second line above, AQ. And hydrogen. Hydrogen's a gas, H2 as a gas, G. All my state symbols are in place. Next, magnesium sulfate solution reacts with sodium hydroxide solution. They're both solutions. Both have AQ, aqueous solution, to indicate their state symbol. They react to form a precipitate. A precipitate would mean a solid that's produced when 2 solutions are mixed. That's magnesium hydroxide. I can see magnesium Mg, hydrogen and oxygen, magnesium hydroxide, it's a solid. And sodium sulfate solution, AQ. Aluminium nitrate solution, in my simple equation, I'll use AQ. Reacts with magnesium sulfate solution, AQ again, to form a precipitate of aluminium sulfate. If it's a precipitate, it's solid. Now, what about my last? I get my solid aluminium sulfate produced. What remains is magnesium nitrate. That would be as a solution. We only ever get one precipitate in a reaction. Here, my MgNO3 twice is aqueous. Ionic equations, final type. They are, of course, only used for reactions where ionic substances are used or made. And we undo the formula. When we looked at making the chemical formula of different substances, it was combining ions so that their charge is balanced. Now we're going the opposite way. It's the reverse of working out the formula of an ionic substance. Na is as a solid and not broken up into ions. H2O is a liquid and not broken up into ions. NaOH, if I dissolve an ionic substance in water, it breaks up to give the ions. Na plus, and I've got two of them. OH minus, I've got two again. And H2 as a gas. And that's it. I can't simplify it in any way. I've broken up my ionic substance NaOH into its constituent ions. I'm done. Next, MgSO4, aqueous. MgSO4 tells me it's ionic. Why? Ionic substances contain metals. Mg is a metal. I'm breaking it up into its ions. Mg2 plus. If I didn't know it was 2 plus, I can look in the periodic table and see that Mg is in group 2. SO4 stays as an ion. Now, if I've got Mg2 plus, to balance, SO4 must have been SO4 2 minus. And my other, NaOH, is aqueous. Aqueous meaning dissolved in water, meaning it's broken up. 2 Na plus, because I've got 2 NaOH and 2 OH minus. Again, Na is a metal, sodium, group 1. Metals make positive ions. It's group 1, so the charge is plus 1. OH minus must be OH minus 1 to balance. MgOH2 is a solid. Keep it as such. Na2SO4. Here I've got my Na plus separated because of it being an aqueous solution, and I've got SO4 2 minus. We figured out that SO4 was 2 minus in the beginning. Because of MgSO4, it still is at the end. Na group 1, charge plus 1. Two of them combined with SO4 must be negative 2. That works. Now I can simplify. The arrow in the middle is telling me how things change in going from the products, going to the products from the reactants. I've got SO4 2 minus to begin with. I've got SO4 2 minus at the end. Nothing changes. Didn't change, I can cancel it out. Mg2 plus only at the beginning, not at the end. 2Na plus at the beginning and at the end cancel out. And so my final ionic equation will only be for the ions that were there at the beginning but not there at the end. Only be concerning the substances that changed. Finally, in this, I'm looking at what's broken into ions and what is not. CaCO3 is a solid, no ions. 2. HCl. I must have 2H plus and 2Cl minus. Aqueous. Aqueous CaCl2, I must have Ca2 plus and 2Cl minus to go alongside it. And if we look at that, there. I didn't break up CaCO3. It's a solid. It's not broken up into individual ions. I do break up the HCl. It's aqueous. 2H plus, 2Cl minus. On the right, Ca, and again, you could use the periodic table if you want to show you that Ca is in group 2, 2 plus. 2 plus as an aqueous ion. Cl, Cl minus as an aqueous ion. H2O and CO2 not ionic. I am almost done, but I notice that I've got Cl2 or 2Cl minus on both sides. That doesn't change. Cancel it out when I come to my final version, which is here. Cancel out the chloride ions. They're there at the beginning and at the end, and I get to my final ionic equation. Last example. I'm seeing two aqueous solutions to begin with. Break them into ions. Mg, group 2, 2 plus. There are two of the NO3 ions. They must be -1. 2 Na plus sodium group 1, but my coefficient tells me there's two of them. And 2 OH minus ions. On the other side, MgOH2 stays as a solid. It's not broken into ions. NaNO3, because of the coefficient, I've got 2 Na plus and 2 NO3 minus. It's dissolved. The ions are free to move. I write them separately. Now to see if anything has not changed. I can see in the start, I've got 2 NO3 minuses. They're there at the end. No change. If there's no change, then I can cancel them out. Let's highlight that one. Keep this one highlighted to show no change. I've got 2 Na plus at the beginning. I've got 2 Na plus at the end. Cancel. And my final answer will now be only concerning those things that changed. 2Mg plus 2OH minus gives MgOH2. Now what I could do, and if this works for you, it will save time, but it won't work for everybody, miss out that central part. I know that MgNO3 twice is broken into ions. I know that NaOH is broken into ions, but I know that MgOH2 is a solid. I know that NaNO3 will be broken into ions. I could go straight from only the MgOH twice is there as a solid. Start with that. And what did I need to make it? Mg2 plus and 2OH minus. Cancels out the middle stage. And that completes the two videos on chemical equations. Thank you. I hope you got something from that. If you did, please like, subscribe. That really helps me. I'll get on to making another video.